Good evening, students. Today we'll try to solve A-level mathematics, pure mathematics. So we'll start from the book of Pearson Edexcel International A-level Pure Mathematics 1 student book. The book is here. So we'll start from first chapter, and that is index law related problem. What you see here in 1.1 index laws. So to know these index laws, first of all, we need to know a little bit about index. Here, 1, 2, 3, 4, 4 laws are given. It is not actually law, it is rule. But we want to start from the beginning. Suppose 2 to the power of 3. I think you can see it. 2 to the power of 3. This 2 is called the base, and the 3 is called index. What you have in this chapter 1. And the whole thing, 2 to the power of 3, is called the power. But normally, when we work with this type of math, we call this 3 as power. So whatever the thing is, we need to know a few rules, and the rule is, first rule is, suppose 2 to the power of 3 multiplied by 2 to the power of 4. Here, if the bases are same, two bases are same, then the index can be added. And one more thing, index is a singular form. The plural form of this word is indices. So from this example, we can make 2 to the power of 7. 3 plus 4, 7. So if we make a rule, it will be like that. In class 6 or 7, you studied this rule. A to the power of m multiplied by a to the power of n. Maybe there are more terms here, it doesn't matter, but minimum these two terms. Here the power can be same or different, it doesn't matter. If the bases are same, we can add the power. So this is the rule 1. Similarly, the rule 2 is a to the power m division a to the power of n. It can be written as a to the power m divided by a to the power n, also same thing. So a to the power m minus n. Another rule given in this book, a to the power m to the power of n. That means if there is a power on another power, the powers will be multiplied each other. So rule 3. Rule 4 here given, ab to the power of n, a to the power n multiplied by b to the power n. That means if the powers are same, power is same, then and the bases are different, then power can be distributed like this way. If there is a to the power a, b, c to the power n, you will write a to the power n multiplied by b to the power n and then c to the power n. So there's no problem with that. So we can go into the exercise where mainly we have to work with expansion. So what is expansion? Expansion means simply you can use these type of multiplications, or the rules are basically associative rule. They are called law, associative law, distributive law. The main purpose is the expansion. Suppose question number, here there is examples are given. From example 1, question number A, this one. So x to the power 2 multiplied by x to the power 5, x will be 2 plus 5, that is x to the power 7. This type of math you can do this easily. If there are constants with the variable, you can arrange the constants together, then work with the powers. So here 2 times 3, that is 6, and r to the power of 2 plus 3, that is 6 r to the power of 5. These are the ways how we'll do this type of math. These are very simple math, you know. And how many examples are here? We can see, we can solve the math 1e also. Here what we have, that is e, a to the power of 3 to the power of 2 and 2a square. Here according to our third rule, if there is a power on another power, power will be multiplied each other. According to that rule, we will multiply 3 with 2 and the 2 of a square, it is the coefficient. So 2a to the power 5 multiplied by a square, so 2 to the power a, 5 plus 2, a to the power of 7. So these are very simple math. In class 7 you have solved, 7 or 6 you have solved this type of math. Now go directly with example 2. Here first math, is a minus 3x, first bracket x minus 4. Here we have to use distributive law. That means we have to break the brackets. So first multiply this minus 3x with 7x. So minus sign, 3 multiplied by 7, that is 21, and x. Here the power of x is 1 and that x power 1. So directly we can write x to the power of 2, but we call sometime x square. Now this minus sign and minus sign, if you multiply them, the power the sign will be plus sign. You know, when same sign multiplied, either it is minus times minus or plus times plus, the result will be always plus. So now 3 times 4, that is 12, and x. Yes, this is the expanded part, that is minus 21x square and plus 12x. That is the answer. So, and now go to example 3. Here, in example 3, you have 3 maths. One is a x to the power of 7 x plus x to the power of 4, and in the denominator we have here x to the power of 3. It is one kind of rational thing where the expression is given as the denominator and numerator type math. Now we can turn the page. I think you can see it. Example 3. A. Our question is x to the power of 7 plus x to the power of 4, and in the denominator we have x to the power of 3. In the numerator we can take x to the power 4 as common. How? This x to the power of 7 can be written as x to the power of 4 multiplied of x to the power of 3, and then this x to the power of 4. In the denominator we have x to the power of 3. Now take x to the power 4 as common. So if we take x to the power 4 as common means one kind of division. First of all, you have to divide, then you have to represent that result using the bracket. Suppose x to the power 4 multiplied by x to the power of 3 divided by x to the power of 3. Sorry, x to the power of 4. Then x to the power of 4, x to the power of 4 cut. The quotient is here x to the power of 3. Similarly, here we can write x to the power of 3, then this plus sign, x to the power of 4 divided by x to the power of 4, that is 1. And in the denominator, previously we have x to the power of 3. Now again, x to the power of 3, and here x to the power of 4 can be written as x to the power of 3, then x to the power of 1, x to the power of 3 plus 1. These are boring type of calculations. Smartly you can do it when you are expert in this type of calculation. Now it is x to the power of 3 and then 1. It is a factorized form. When the question comes to simplify these expressions, then it is better if you represent it in the simplified form. So x to the power 1, x to the power 3, it is x to the power 4 and then x. This is the result of the example A, that is x to the power 7 plus x to the power 4 divided by x to the power 3. Now we go to the exercise. Exercise 1A. There is huge number of math here, but we will solve few maths which is important. Exercise 1A from this book, page number 3. Start from 1. The question is, simplify these expressions like this one. Simplify this expression x to the power of 3 plus multiplied by x to the power of 4. So x to the power of 3 multiplied by x to the power of 4. You can write x to the power of 3 plus 4, x to the power 7. This is a math using multiplication rule. Now go to the division rule. where you have division rule A, B, C. 1C. Here k to the power of 3 divided by k square. So what we have, k to the power of 3. If you shift this denominator k square to the numerator, its power will be, the sign of the power will be changed. So even if you directly follow the rule a to the power m divided by a to the power n, directly you can write a to the power m minus n. So according to that rule, you can write k to the power of 3 minus k to the power of 2, that is k to the power of 1, and k to, if you have 1 as power, then you don't need to put that one. This is the answer. So one is our multiplication rule, another one is division rule. Now 1D is also important, where we work with the constants given here. Now if these numbers are multiplied each other, suppose 4 multiplied p to the power of 3, and here in the denominator we have 2p, so 2 goes to 4, that is 2, and p goes to p to the power of 3. Directly you can write 2p to the power 3 minus 2 and 3 minus 1, that is 2p to the power of 2, or 2p square. Another a little bit difficult math, if we go with that, that is 1h. Here we have p to the power of 3 to the power of 2, and then division p to the power of 4. So now we have a rule, that is, if there is a power on another power, power will be multiplied each other. That rule will apply here. So p to the power of 3 to the power of 2, that is 2 times 3, that is 6, division p to the power of 4, so p to the power of 6 minus 4, and that is p square. Now we can go further, more calculations, where I is another important math, that is 2a to the power of 3 to the power of 2, division 2a to the power of 3. Here one thing very important, that first solve this math, then we will discuss other things. We had a rule, if the bases different, power are same, then power will be distributed with each base. So here similarly, 2a to the power 3 whole to the power of 2, here we can write 2a square, and a to the power of 3 to the power of 2, directly we can write a to the power of 6, and now 2a to the power of 3. So here we have 4a to the power of 6, and for division, immediate next number 1 by 2a to the power of 3. So now we can simplify. 2 goes to 4, that is 2. A to the power 3 goes to a to the power 6, that is 6 minus 3, we can write 2a to the power of 3. Here one very important thing, if 2 is the coefficient of a to the power of 3, if the calculation were, suppose a to the power of 3 to the power of 2, division 2, and there is a cross multiplication instead of here dot multiplication. multiplications are two types. One is dot multiplication, another is cross multiplication. Here 2, nothing is given, a to the power of 3. Here we can imagine there is a dot. So these kinds of multiplication is called dot multiplication. But here there is a cross sign. There is a cross multiplication. So most of the time they are same, but when we simplify those things, a little bit different. Dot and cross multiplications. It is another application also in vector geometry. They have different thing. Suppose here 2 square, that is 4a to the power of 6. Division, if you convert it into multiplication, it will take immediate next value here. That means 1 by 2, and this a cube will remain on the numerator. So the result will be different. 2 goes to 4 2 times, a to the power 6 plus 3, that is a to the power 9. Look, the result is completely different. Here 2 to the power 9, and in question number I, where we used dot multiplication, the result is 2a cube. So during the exam, you have to be careful if you see this type of difference. I think you are clear now. For more things, go to question number Q, 1Q. Here 2a cube, division 3a square, and then a to the power of 5. Look what I discussed here. Same type of calculation you will see here. Now first term, a to the power a2 multiplied by a to the power 3, that will same. Then division, so 1 by 3a square. This division will not touch after this cross multiplication. So you have to write here 6a to the power 5 on the numerator. Now 3 goes to 6 2 times, and then a square goes to a3 a times. You can divide a to the power 5 also by the a square. Result will be same. So 2 multiplied by that 2, and here we have a to the power of 5, all the remaining term here. So 4 a to the power 1 and 5, that is 6. That is the answer. So I think you are clear in this type of math, and in question number 1 you will have no problem. Now go to question number 2. In question number 2, we have expand and simplify if possible. So here the simple maths are, you know them. So A is 9. Question number 2, A, 9 into x minus 2. I think this type of math you can solve it by yourself. Go to a little bit different maths. So how can I solve it? Go to the last 3 maths. So we have to go to the next page. Here we have these 3 maths. One is for t, that is 3x square minus x into, that means there is a bracket here, x into 3 minus 4x, bracket close, that is 7. So start from those maths. The beginning maths, they are very easy. I think we can solve it easily. Go for question number 2T. That is 3x square minus x 3 minus 4x plus 7. Here expansion means you have to expand as much as possible. First of all, you have to omit the brackets. Then you have to arrange the like terms together. 3x square minus x times 3, that is 3x, plus, minus minus plus x times 4x, that is 4x square. Distributive law is applied here, and that is done. And the rest of the part is 7. So here 3x square and 4x square, they are like terms. Why they are like terms? Their powers are same. Maybe the coefficients are different, but powers are same. So 3x square and 4x square, that is 7x square, minus 3x. We'll write 3x because there are no other terms where we have the highest power 1 and the other part is 7. So that is done. It is a quadratic expression. Quadratic expression means where the highest power is 2. When the highest power is 3, they are called cubic equation. You know that. So now the next math, U. 4x into x plus 3. That means using bracket we have done this. So twice x, 3x minus 7. So now 4x. Here the coefficient of x inside the bracket is 1. So we can write 4x square plus 3 times 4, that is 12, and x minus 2 times 3, that is 6, x times x square, minus minus plus. You have to be careful here because after this multiplication the sign are changing. So minus minus plus. 2 times 7, that is 14, and then x. So here 4x square minus 6x square. First of all, you will find the difference between the numerically given number 6 minus 4, that is 2, and x square, and you will put the sign which is behind the bigger number, that is 6. Behind 6 there is minus, that is why you will do. This can be taken as a rule. Otherwise, directly, suppose you have a loan of 6x square, you are paying 4x square, the remaining part is minus 2x square. Now 12x and this 14x, they are like terms. Maybe the coefficients are different, but the power of x, they are same, and behind them same sign, that is we have to add them. So 14 and 12, if we add 4 plus 2, that is 6, and that is 2 here, x. So twice x square plus 26 x. How much time? My target is to finish the class within half an hour. Only 2 minutes left. So I have to take few more minutes. I think it will be better for you. Go for V. 3x square, here twice x plus 1 minus 5x square, 3x minus 4. Yes, similarly 3 times 2, that is 6, x times 2 here and here 1, directly you can write. Now you are expert now, so you can do it. So 3x square, this 3x square minus 5 times 3, that is 15, and x square and x cube, minus minus plus 5 times 4, that is 20 x square. So the like terms here, 6x cube and 15, so minus 9x cube, and 3x square and plus 20x square, that is 23x square. Done. Go for the third math. Third math, simplify these fractions. Same type of calculation we have done in example 3. Now go for the exercise maths. So 6ax to the power of 4, 10x to the power of 6 divided by twice x. So this type of math you can solve in two ways. Directly you can divide two terms by the denominator. Otherwise you can take common of a few terms from the numerator and you can simplify with the denominator. So I follow normally. First take HCF here, 6 and 10, where HCF is 2, and take here we have highest power 1, that is take x. So 2x, so 3x cube divided by x, that is 3x, not x to the power 4 divided by x, that is x to the power 3, and 10 divided by 2, that is 5, and x to the power 6 divided by x, x to the power 5. And the numerator you have another 2x. So 2x cut. The simplified form is 3x to the power of 3, 5x to the power of 5. So that is your simplified form of the answer. And we'll go directly to the last math. Here you have 6 maths. First one and last one I will solve it. Question number F. Go for 3F. Here 9x to the power of 5 minus 5x to the power of 3 divided by 3x. Now we will follow the other rule. Distribute this 3x with 9x to the power 5 first time and secondly 5x to the power 3. That is another rule. It will be the best option if you choose which one is applicable or which one is interested by you. So 3 goes to 9, that is 3. X to the power of 5 divided by x, it will be x to the power of 4 minus 5 cannot be divided by 3. So there will be a fraction here, 5 by 3, x cube divided by x, that is x square. So this term will remain here. You cannot do anything. Otherwise you can make mixed fraction here. 3x to the power of 4 minus 3 goes to 5 one time and then 2 by 3 x square. You can represent in this way also. It depends on you. Normally we don't keep improper fractions. That is why I have written. So exercise 1A is done. I think rest of the maths you can solve it easily following the solutions I have given here. So that is end of the class for today. Thank you. Bye bye.